So this week we will actually start working on the design of software. We'll introduce the medical software lifecycle, the organizing principle for a software project, and over the next 5 to 6 weeks, we will work through the individual steps of the cycle. So today we'll do the big overall introduction, and we'll pick up each piece week 6 to 10, 11 of this class. So our goals for this week is to introduce software lifecycles. We'll discuss the IEC 62304 standard, the international standard that governs medical software lifecycles, and we'll introduce our example project of image-guided neurosurgery, which we'll use to anchor our discussion of the steps in the software lifecycle, at least the first part of the cycle. The outline will introduce lifecycles and the standard in the first couple of segments. In the next 2 segments, we'll introduce the example project, the image-guided neurosurgery project, and we'll give a guided tour of the lifecycle process. And then the last segment, we'll talk about information transmission, this whole very important topic, so how information gets conveyed from the user to the business analyst, to the software developer engineer, to the coder, etc. We are still following the textbook, and this week's material comes from chapter 10 of this book. So we'll get started. This is our introduction segment to life cycles and the IEC 62304 standard. The reason we care about life cycles is that it's explicitly mandated in the guidance here. So from the FDA's General Principle of Software Validation, we have the statement that this guidance recommends an integration of software lifecycle management and risk management activities. While this guidance does not recommend any specific lifecycle model, it does recommend that software validation and verification activities be conducted throughout the entire software lifecycle. So the conclusion of this, of course, is that we must use a lifecycle model. Now, note that the guidance does not recommend any specific one. They don't force you to use any one, but you have to have one. And while the documents speak as if they're using a waterfall, that's just for illustration only. So here is the standard itself. This is IEC 62304. This is the original edition. This comes from 2006. And then this is the amendment that came out in 2016. And this is the fundamental document that governs medical software. Now, unfortunately, 2016 is before the machine learning age, so it's a little bit out of date. So hopefully there'll be a revised version of this soon, but it's still a fundamental document for us to follow. So let's look at this document. So the introduction is actually very interesting. It has a statement that says that this standard provides a framework for lifecycle processes with activities and tasks necessary for the safe design and maintenance of medical device software. So the goal is safe design and maintenance, of course. As a basic foundation, it is assumed that the medical device software is developed and maintained within a quality management system and a risk management system. And this is exactly what we talked about last week. 4.1, 4.2 here refer to sections in the document there. This is the material we covered in the previous week, and it's worth keeping in mind that everything that the standard talks about assumes that you have a quality management system and a risk management system in place. This is the outline of the document. You can kind of see the heart of the document is section 5, which is the software development process. But a very important section is also section 6, which talks about the software maintenance process. And for the most part, this is a duplicate, so it tells you what's different about maintenance and the initial development. But those are very important sections. And then there are 4 annexes, of which Annex B is very readable and very educational. If you ever get your hands on this document, it's well worth reading. As by now you should be expecting, any medical regulatory document, any standard, at some point you'll hear the word risk classification. The standard defines software into 3 classes: Class A, low or acceptable risk; Class B, unacceptable risk, but the injury is not serious, potential injury is not serious; Class C, it's an acceptable risk that can lead to a serious injury or death. This is similar to the Class 1, Class 2, Class 3 that the FDA recommends. It's simply a matter for the software component of a project. And remember, a lot of these documents came from an era of medical devices where the software was part of a larger device. Just to explain this, there's a very interesting blog post I came across from Cyril Michaud from MD11 Consulting. You can see the link at the bottom. And he explains Class A, Class B, Class C in terms of a nurse using a thermometer which gives a wrong value. Now, what would we classify this system? And we're talking about a system here, the nurse plus the thermometer. The system is Class A, low risk. If the thermometer gives the wrong value, then the nurse is going to touch the forehead of the patient or redo the measurement with another thermometer or check the blood pressure of the patient to confirm the fever. No damage is possible. So this is Class A. Even if the software gives the wrong answer, the human in the loop can make sure that this does not result in any harm. Class B, the thermometer gives the wrong value, and then the nurse may give a wrong treatment to the patient. So there's no checking by human here. However, there is no chance that this may endanger the patient. So now with Class B, something could actually cause harm to the patient, but it's not particularly serious harm. And then Class C, so as you'd expect, then the nurse is going to give the medicine to treat the fever. The wrong medicine may endanger the patient and eventually cause death. Now we're into Class C, and now our requirements are significantly higher for what's expected. So that's Class A, Class B, and Class C, and we'll return to this over the next few weeks. So what is the impact of this classification? There are more requirements, as you would expect, from Class B and Class C software. So Section 5 states, the manufacturer shall subdivide the software until it's represented by software units for classes B and C. So this statement can be found throughout the standard, and the process must be most rigorous for software that can cause more serious harm. And this is the essence of all risk classification, both at the FDA level and in the standard. So higher risk software requires more work. You need to do a more detailed design, you need to do more detailed testing, you have to have smaller pieces, which is the subdivision, that the statement that we quoted from before. And as you go from A to B to C, or Class 1 to Class 2 to Class 3 in the FDA sense, you have to do more. Higher risk software requires more detailed design, requires more care, it requires more evidence to ensure that we know what we're doing, we're not exposing patients to risk that's unnecessary and potentially dangerous for them. So what is a life cycle? A life cycle is a collection of steps. So you can see this waterfall model. We'll come back to this in a couple of slides. We have system requirements, software design, software implementation, verification and validation, release and maintenance. So the standard defines this as a conceptual structure spanning the life of the software from the definition of its requirements to its release. So this is IEC 62304. There are different life cycles, and what these life cycles essentially are different arrangements of these blocks. Do we do them only once? Do we do them in a cycle? Do we go back and forth? But the fundamentals are just these blocks. So we will talk about them in a little bit more. So the most basic life cycle, and the one that everybody uses when they first start doing any kind of software work, is what one could define as the code and fix life cycle. You write something, you hand it to your user, they find something wrong, you fix it, and you keep going around and around. This is not what you want to be using, right? This is not appropriate for a medical device, a medical product, anything that entails risk to the patient. But this is how a lot of software actually gets developed when people do it at an amateur level, at least. The standard classifies life cycles using these three characteristics here. So first we have the waterfall, and the waterfall is an one-shot process from customer needs to delivery. We have incremental life cycles where the customer needs and the requirements are done once, and then we do multiple cycles, each adding capabilities. And then finally, we have evolutionary life cycles where the user needs cannot be fully understood at the beginning, so the requirements cannot be fully defined in front. So in each iteration, we revisit the whole process. So let's just look at this in a little more detail in the next table. So development strategy is the first column. Do we define all the requirements first? Do we have multiple cycles? And do we distribute interim software? So for the waterfall, yes, we define all the requirements first, and no, we do not have multiple cycles, and we do not distribute interim software. For an incremental process, we define all the requirements first, but then we use multiple cycles. And in each cycle, we implement, we test, maybe we release the software, and then we go back and we implement a little bit more, and we go through it. So it's a sort of a slower, more gradual process. And then the full evolutionary cycle, where we cannot define all the requirements first. So by definition, we have multiple cycles and multiple releases. And as we go through each cycle, we use the knowledge gained to improve the requirements to understand a little bit of the user. And this is fundamental. If you know exactly what you're doing, you could theoretically go for a waterfall. We're going to design the software, implement it, test it, release it all in one go. The incremental process basically says, yes, we can define it, but what we're going to do just to make sure is we're going to release a first release. We're going to create a first version of the software that doesn't have all the features, use that to then develop a second release, a third release. So we're doing a little bit of testing as you go through. It reduces the risk potentially as well. The evolutionary cycle says we can't. We do not understand completely what our users need. So we'll make a version, we'll send it out to them, we'll get feedback. Based on that, we may have to update our designs, change the requirements, go back, create a second version, a third version, until we converge to something. So this is the waterfall. This is this incremental process, one step at a time. And it's called a waterfall because it follows the flow of water down a waterfall. There's no going up here. It's on one pass throughout all the steps. It's an all or nothing life cycle, so we do not have incomplete prototypes at any point, and these are very useful for testing sometimes, and they also allow identification of issues. So the waterfall assumes that you know exactly what you're doing. The FDA does not prescribe this, though many documents use it for illustration. Both the FDA, the MDRF, the standard are all written as if you're using a waterfall, but that's just because it's the easiest one to explain. Let's go to the other end of the process. Let's look at the evolutionary life cycle. Here you do an initial requirement analysis and design. You create a version of the software. You release this interim version to your customers. You get feedback. Based on the feedback, you obtain the design. You create another version. And you go around this loop as many times as you need, maybe a few times, maybe every few months. You create another version. You may release 4, 5, 6 versions until the thing is complete, and then you release your final version to your customers. Now, again, what I would like you to remember as we move to the next segment here is that the different life cycles are govern how the pieces are connected. The individual pieces, how does one do requirements, how does one design software, how does one implement, how does one test, are the same regardless of the life cycle. It's just the arrangement that changes between the different life cycles. So what we will talk about from here on out in this class, in this week and the rest of this class, is that we're going to pretend that we're talking about the idealized waterfall model and just describe the steps. But remember that in practice, the steps could be done in different orders depending on the life cycle model you choose to follow. So with that, we'll end this segment, and in the next segment, we'll continue our discussion of the standard and the lifecycle model. Thank you.